Hi Tower, this is Captain Sims, Flight 888 from Beijing, en route to LAX. Got a question for you. We're getting some really weird stuff going on up here. As we go over the poles, we're getting real strange noises, beautiful lights, but just wanted to know if there's anything...
You're a 47-year-old male?
Do I look like a male to you?
Security!
No, not security. No. I demand a lawyer! I needed this flight so bad! Come on, guys! What are you guys doing? No!
Hello. How are you doing? You're late.
So boring.
Would you guys like some refreshments?
Yes,
Please.
Thank you.
Could I get a cup of coffee when you have a chance?
I don't want that.
Thank you.
Ladies and gentlemen, this is Captain Sims from the flight deck. Looks like we're going to be experiencing some turbulence. Please return to your seats and make sure your seatbelts are securely fastened. Thank you.
Whoa, oh God!
Hi Tower, this is Captain Sims, Flight 888 from Beijing en route to LAX. Got a question for you. We're getting some really weird stuff going on up here. As we go over the pole, we're getting real strange noises, beautiful lights, but just wanted to know if there was anything we should...
Andrew, what's going on? We just lost all radio communication towards the plane.
Oh no, take a seat. Let's have a look and see what's going on. Okay, wow, look at that. The sun is really active at the moment, and any one of these could have caused a flare, and wow, nice big, this is where the aurora is hitting, so that means they probably lost communications. I think it was a solar flare which did it. So what the solar flare does is it ionizes the atmosphere, so that's the upper part of the atmosphere gets hit by all these photons, and then particles are going to come streaming in as well, and it's going to knock electrons off these things. And the way that the radio works is it bounces off this layer. It's called the ionosphere. And by changing the properties of this ionosphere, the radio waves don't bounce the same way anymore. So
What do you think they'll do?
if they're sensible, they'll turn south. They'll probably head to Alaska. My bet is Fairbanks would be where they'll land. They're flying over the pole. They haven't got enough fuel to get to LAX. They've probably lost GPS, but they'll still have inertial navigation, which is just working with gyroscopes, so they'll be able to get close enough. And as soon as they get below 70 degrees north, then they'll have ground communication again. So they can have a large current in the Earth's electric grid because of this. And in the worst case, if they don't take care of it, then they're going to start blowing up transformers. And the satellite operators as well, they're going to be worried about this. Losing communications or breaking or that sort of thing. And worse still, if this is a really big flare with a really big, what's called coronal mass ejection coming with it, it'll heat the Earth's atmosphere up, which will expand, and that'll mean the satellites will sort of start falling out of orbit. So if I'm a satellite operator, I'm making sure that my satellite is okay and prepared for this.
Hello, I'm Zuleyka, and I was on a plane from Beijing to California,
and there was a solar flare, and I came here to see how you could prevent that happening again.
We can do nothing, unfortunately, to stop the solar flares, but we are building at last the next generation of sensors which measure the solar flare when it's happened, and we're working on ways of trying to predict when it's going to happen, which is what everybody wants. So as you see, they're just very small little satellites. This is a complete satellite, a model of one, obviously. And what we want to do is to sort of make these satellites and put them up and look at the sun all of the time. And that way we get a much better picture of what the sun's doing. And this sort of thing is being built by students here at LASP. So this strap is made of metal, and what it's doing is called grounding me, which means that any static electricity which I have moving around on the chair or anything moving around, if I touch this, without this, it could zap some of the sensitive electronics in here. So this mat here is connected to ground, I'm connected to ground, and that means that everything here should be safe from static electricity. The key question. We don't know a solar flare is happening until it starts. We're at such a low level of understanding of these events that it's really reactionary. So there's also the fact that solar flares really affect us on Earth. We need to be able to say, when's it going to happen? So that's the important thing to almost all of the population.